What if I told you that our ancestors were creating technology so advanced that even today's engineers are scratching their heads trying to figure out how they did it? What if the past wasn't as primitive as we've been taught, but instead filled with brilliant minds creating devices that seem to defy the very timeline of human progress? Tonight, we're diving into the most mind-bending ancient inventions that challenge everything we think we know about technological development. These aren't your typical stone tools or pottery fragments. These are sophisticated machines, precision instruments, and materials so advanced that some of them took us thousands of years to reinvent. Before we begin this journey through time, take a moment to hit that like button if you're ready to have your mind blown, and subscribe if you love exploring the mysteries of our past. Drop a comment and let me know which ancient civilization you think was the most technologically advanced. Now settle in, because we're about to explore devices that will make you question whether our ancestors were far more brilliant than we ever imagined. Picture this. You're walking through a museum and you come across what looks like a modern computer, but the placard next to it says it's over 2,000 years old. Your brain would probably short-circuit trying to process that information. Well, that's exactly what happened when archaeologists discovered our first incredible device. In the year 1900, Greek sponge divers were working near the island of Antikythera when they stumbled upon an ancient Roman shipwreck. What they found would completely rewrite our understanding of ancient Greek technology. Among the treasures pulled from the Mediterranean seafloor was a corroded bronze object that looked like nothing anyone had ever seen before. At first glance, it appeared to be just another piece of ancient junk. But this corroded lump of metal was about to reveal itself as the world's first analog computer. The Antikythera mechanism, as it came to be known, was built around 100 BCE. That's way before the first iPhone, way before the first computer, way before pretty much any technology we consider remotely modern. Yet somehow, the ancient Greeks packed incredible computational power into a device about the size of a shoebox. This extraordinary machine represents technological sophistication that we didn't think existed until the Middle Ages. When researchers finally managed to peer inside this ancient device using modern imaging technology, what they discovered defied all expectations. The mechanism contained over 30 intricate bronze gears, dials, and pointers, all working together in perfect harmony. It was like opening up a modern Swiss watch and finding it buried in an Egyptian pyramid. The level of precision and engineering prowess required to create such a device was absolutely staggering. But here's where it gets really incredible. This wasn't just some decorative trinket or religious artifact. The Antikythera mechanism was a fully functional astronomical computer designed to predict celestial events with mind-boggling accuracy. It could track the movements of the sun, moon, and planets. It could predict eclipses years in advance. It could model the cycles of the entire solar system. We're talking about computational abilities that wouldn't be seen again until the invention of modern clockwork mechanisms, over 1,000 years later. The device's capabilities were so advanced that when it was first studied, many experts refused to believe it could actually be ancient. How could a civilization without electricity, without modern mathematics, without any of the tools we consider essential for precision engineering, create something so sophisticated? The answer challenges everything we think we know about technological progress. Modern analysis has revealed that the mechanism's creators possessed advanced knowledge of mathematics, astronomy, and mechanical engineering that was supposedly lost to history. They understood gear ratios, differential mechanics, and complex astronomical calculations. They could predict the movements of celestial bodies with precision that rivals modern computers. Even today, with all our advanced imaging systems and preservation methods, the mechanism's full capabilities remain partially mysterious. But the Antikythera mechanism is just the beginning of our journey. Let's travel from ancient Greece to ancient Mesopotamia, where archaeologists discovered something that would make any modern electrical engineer do a double take. In 1936, German archaeologist Wilhelm Koenig was working near Baghdad when he made a discovery that would spark decades of controversy and wonder. Buried in the ruins of what was once the capital of the Parthian Empire, Koenig found a ceramic jar that contained something extraordinary. Inside the jar was a copper tube, and inside that tube was an iron rod. When assembled together, these three components created what appeared to be an ancient battery. The Baghdad battery, dating back to around 250 BCE, consists of these three distinct objects fitted together to create a single device. Now you might be thinking, surely ancient people couldn't have understood electricity. But modern replicas of this device have demonstrated something remarkable. When filled with an acidic solution like vinegar or wine, the Baghdad battery can actually generate electrical current. We're talking about voltages ranging from 0.8 to nearly 2 volts. Think about what this means. Over 2,000 years ago, someone in ancient Mesopotamia understood that combining two different metals with an electrolyte solution could produce electricity. They grasped principles of electrochemistry that we didn't formally understand until the 18th century. The implications are staggering. But what were they using this electricity for? That's where the mystery deepens. The original theory suggested it was used for electroplating, a process where electrical current is used to coat objects with thin layers of metal. This would explain how ancient artisans achieved such precise and durable metal finishes on jewelry and decorative objects. However, no definitively electroplated objects from the same time period have been discovered, leaving us with more questions than answers. Some researchers have proposed alternative uses. Perhaps these devices were used in religious ceremonies, creating small electrical shocks that worshippers might have interpreted as divine intervention. Others suggest they could have been used for medical treatments, as electrical stimulation has been used therapeutically throughout history. The truth is, we may never know exactly what our ancestors were doing with their ancient batteries. But the fact that they existed at all forces us to reconsider what we thought was possible in the ancient world. Connected in series, a set of these batteries could produce much higher voltages, though no connecting wires have ever been found to prove this was actually done. Still, the potential was there. Ancient engineers had stumbled upon one of the fundamental principles that would eventually power our modern world. From electrical mysteries, let's journey to another technological marvel that has baffled experts for centuries. We're heading to the medieval Middle East, where master craftsmen created a material so superior that modern science still struggles to replicate it perfectly. Damascus steel represents one of history's most legendary lost technologies. This wasn't just any ordinary metal. Damascus steel blades were renowned throughout the ancient world for their incredible sharpness, flexibility, and distinctive watered patterns. Legends claimed that a Damascus steel sword could slice through the barrel of a rifle or cut a falling silk scarf in midair. These weren't just stories. Damascus steel possessed properties that made it genuinely superior to almost any other metal of its time. What made Damascus steel so special? Recent scientific analysis has revealed something absolutely extraordinary. German researchers studying ancient Damascus blades discovered that they contained carbon nanotubes and nanowires. Yes, you heard that correctly. Nanotechnology in medieval metalwork. These microscopic structures, which we've only recently learned to create intentionally in modern laboratories, were somehow being incorporated into steel over 1,000 years ago. The nanotubes likely came from plant fibers that were added during the forging process. These organic materials, when subjected to the intense heat and pressure of steel forging, transformed into carbon nanostructures that strengthened the blade significantly. The ancient smiths didn't understand the science behind what they were doing, but they had stumbled upon manufacturing techniques that put them centuries ahead of their time. But here's the frustrating part. Despite all our modern knowledge and technology, we still can't perfectly recreate Damascus steel. The secret lies not just in the technique, but in the raw materials themselves. The steel was made from Wootz steel, which came from specific ore deposits that were rich in particular impurities. Over time, these ore veins became depleted, and the exact combination of minerals that gave Damascus steel its unique properties was lost forever. The loss of Damascus steel technology wasn't just about depleted resources, it was also cultural. The techniques for forging these incredible blades were closely guarded family secrets, passed down from master to apprentice through generations of smiths. When political upheaval and changing trade routes disrupted these traditional workshops, the knowledge died with the craftsmen who possessed it. Today, modern steel can outperform Damascus steel in most practical applications. We have alloys that are stronger, more durable, and more consistent than anything ancient smiths could produce. But there's something almost mystical about the fact that medieval craftsmen achieved such incredible results with relatively simple tools and techniques. They were working at the very limits of what was possible with their technology, pushing the boundaries of metallurgy in ways that wouldn't be fully understood for centuries. The watered patterns on Damascus steel weren't just decorative. They were visible evidence of the complex internal structure that gave these blades their legendary properties. Each pattern told a story of carbon distribution, folding techniques, and heating cycles that had been perfected over generations. When you held a Damascus steel blade, you weren't just holding a weapon, you were holding centuries of accumulated knowledge and craftsmanship. The story of Damascus steel teaches us something profound about human ingenuity. Sometimes our ancestors achieved technological breakthroughs not through complex scientific understanding, but through generations of careful observation, experimentation, and refinement. They didn't need to understand carbon nanotubes to create them. They just needed to pay attention to what worked and what didn't, building on centuries of accumulated wisdom. This brings us to our next mind-bending ancient technology, one that challenges our assumptions about Roman engineering capabilities. We all know the Romans were impressive builders. The Colosseum, the aqueducts, the roads that still exist today. But what if I told you they created a construction material so advanced that our modern concrete seems primitive by comparison? Roman concrete has been the subject of intense scientific study in recent years, and the results are absolutely staggering. While our modern concrete begins to deteriorate within decades, Roman structures have been standing strong for over 2,000 years. The Pantheon in Rome, with its massive concrete dome, has weathered countless storms, earthquakes, and the passage of millennia. It's not just surviving, it's thriving. But here's the truly incredible part. Roman concrete doesn't just resist decay over time. It actually gets stronger. Modern researchers have discovered that Roman concrete possesses self-healing properties that allow it to repair its own cracks naturally. When water seeps into tiny fissures in the material, it triggers chemical reactions that literally rebuild the damaged areas. It's like having construction material that comes with its own built-in maintenance system. For centuries after the fall of the Roman Empire, engineers and architects tried desperately to unlock the secrets of this superior concrete. They knew it existed. They could see Roman buildings still standing while their own constructions crumbled. But the exact formula remained stubbornly elusive, lost in the chaos of imperial collapse. Only recently, in 2023, did modern scientists finally crack the code. The secret lay in two key ingredients that Romans used but we abandoned. First was quicklime, a highly reactive form of limestone that creates those self-healing properties. Second was volcanic ash, which the Romans had in abundance thanks to their proximity to active volcanoes like Vesuvius. The manufacturing process involved creating what researchers now call lime clasts, millimeter-scale calcium-rich mineral deposits scattered throughout the concrete. When cracks form in the structure, these lime clasts react with water to seal the damage automatically. It's an elegant solution that demonstrates sophisticated understanding of material science. To prove their theory, modern researchers created samples using both ancient and modern formulations. They deliberately cracked them and ran water through the cracks. The Roman-style concrete healed itself. The modern concrete didn't. After 2,000 years, we finally learned that our ancestors weren't just lucky, they were brilliant. But Roman concrete is just one example of ancient material science that surpasses modern capabilities. Let's journey to the Byzantine Empire, where military engineers developed a weapon so devastating and so mysterious that it remained unmatched for over 7 centuries. Greek fire was the ultimate ancient superweapon, an incendiary device that could burn on water and devastate enemy fleets with terrifying efficiency. Imagine being a sailor in the medieval period, watching in horror as your wooden ship erupts in flames that can't be extinguished by water. That was the reality of facing Byzantine forces armed with Greek fire. The weapon system itself was sophisticated for its time. Bronze tubes mounted on ships could spray the burning mixture at enemy vessels or launch grenades filled with the mysterious substance. The delivery mechanism included siphon pumps and swiveling nozzles that allowed precise targeting. Modern experiments suggest the system could achieve flame temperatures exceeding 1,000 degrees Celsius, with an effective range of up to 15 meters. But the real genius of Greek fire wasn't just its destructive power. It was the secrecy surrounding its creation. The Byzantine Empire treated the formula as the ultimate state secret. Emperor Romanos II declared that 3 things must never fall into foreign hands: the imperial regalia, any royal princess, and the secret of Greek fire. The first 2 were occasionally given away for diplomatic purposes. The third never was. This level of security wasn't just paranoia, it was strategic brilliance. Greek fire gave the Byzantine Empire a decisive military advantage that helped them resist invasions for centuries. Enemy forces knew about the weapon's existence and feared it, but they couldn't replicate it. Even when samples of the mixture and delivery apparatus were captured, foreign engineers couldn't make them work properly. Modern analysis suggests that Greek fire was based on petroleum mixed with various resins, creating something comparable to modern napalm. But the exact proportions and additional ingredients remain a mystery. The formula died with the empire, taking with it one of history's most effective military technologies. The psychological impact of Greek fire was just as important as its physical destructive power. Enemy commanders had to factor in the possibility of facing this terrifying weapon when planning naval operations. The mere threat of Greek fire could influence strategic decisions and diplomatic negotiations. It was a force multiplier that extended far beyond its actual battlefield effectiveness. From the waters of the Byzantine Empire, let's travel to ancient China, where a brilliant polymath named Zhang Heng created the world's first earthquake detection device nearly 2,000 years ago. In a time when seismic events were interpreted as messages from heaven, Zhang Heng applied scientific principles to create something that wouldn't be matched until modern times. Zhang Heng was the kind of Renaissance mind that seems almost impossible. He was simultaneously an astronomer, mathematician, engineer, geographer, and inventor. He created the first water-powered armillary sphere for astronomical observation. He improved the water clock. He documented over 2,500 stars in a detailed catalog. He even invented what many consider the first odometer. But his earthquake detector was the invention that created the greatest impact. The device was magnificent in both form and function. Standing almost 6 feet in diameter, this bronze vessel resembled an ornate urn, decorated with 8 dragons positioned around its circumference. Below each dragon sat a bronze toad with its mouth wide open, ready to catch whatever might fall from above. The mechanism was elegantly simple, yet incredibly sophisticated. When seismic waves reached the device, they would trigger an internal pendulum system that caused one of the dragons to release a bronze ball into the corresponding toad's mouth. The direction of the earthquake was indicated by which toad received the ball. It was directional earthquake detection that pinpointed not just that a seismic event had occurred, but where it originated. The device's accuracy was demonstrated in the most dramatic way possible. Historical records tell us that on one occasion, one of the dragons released its ball despite no perceptible earthquake in the capital. Scholars were baffled by this apparent malfunction. Several days later, a messenger arrived with news of a major earthquake 400 miles away, in the exact direction indicated by the device. The mysterious power of Zhang Heng's instrument became legendary. In 2005, Chinese scientists successfully replicated Zhang Heng's seismoscope and tested it against simulated earthquakes based on real seismic data from China and Vietnam. The ancient design detected all of them with accuracy that matched modern seismometers. After nearly 2 millennia, Zhang Heng's engineering brilliance was finally validated by contemporary science. What makes Zhang Heng's achievement even more remarkable is that he was working purely from theoretical understanding. He couldn't analyze seismic waves with modern instruments or study earthquake patterns with computer models. He had to deduce the principles of seismic detection through observation, mathematics, and intuitive genius. The fact that his device worked so effectively proves that ancient minds could achieve technological breakthroughs that rival our modern capabilities. These examples force us to confront an uncomfortable truth about our assumptions regarding technological progress. We tend to think of advancement as linear, with each generation building steadily on the achievements of those who came before. But history tells a different story. Sometimes ancient civilizations achieved technological peaks that were lost for centuries, only to be rediscovered or reinvented by later cultures. The question that haunts researchers studying these artifacts is simple yet profound. If our ancestors could create analog computers, generate electricity, forge superior metals, develop self-healing concrete, invent devastating weapons, and detect earthquakes with such precision, what else were they capable of? What other technologies did they develop that we haven't discovered yet? And perhaps most unsettling of all, what knowledge did we lose that we still haven't managed to recover? To recover? But our journey through impossible ancient technologies is far from over. Let's travel to South America, where we encounter stonework so precise that it makes modern construction techniques look clumsy by comparison. High in the Bolivian Andes, at an altitude that makes breathing difficult and thinking even harder, sits one of archaeology's most perplexing mysteries. Pumapunku, part of the ancient Tiwanaku complex, showcases stone cutting and fitting techniques that shouldn't have been possible with the tools available to pre-Columbian civilizations. When you first see photographs of Pumapunku, your brain struggles to process what you're looking at. Massive blocks of red sandstone and andesite have been cut with such incredible precision that they fit together like pieces of a three-dimensional jigsaw puzzle. No mortar was used. No gaps exist between the stones. The joints are so tight that you can't slide a piece of paper between them. But here's what makes it truly mind-bending. These aren't rough-hewn blocks that were somehow forced to fit together through brute force and determination. Every surface is perfectly smooth. Every angle is precisely 90 degrees. Every edge is sharp enough to cut paper. The uniformity is so exact that individual blocks could theoretically be swapped with others while maintaining perfect structural integrity. The largest of these perfectly cut stones weighs over 130 metric tons. That's roughly equivalent to 200 modern automobiles stacked on top of each other. Moving such massive weights across difficult terrain would challenge modern construction crews with cranes and heavy machinery. How did ancient engineers accomplish this feat using only human labor and simple tools? The precision extends beyond mere stone cutting. Intricate decorative motifs carved into the blocks feature interior angles that are impossibly sharp. The crisp 90-degree corners and complex geometric patterns show no evidence of the tool marks you'd expect from hammerstone work. The finishing quality suggests manufacturing techniques that we associate with modern machining rather than ancient craftsmanship. Archaeological analysis has revealed something even more puzzling. The technical finesse displayed in these blocks suggests the possibility of prefabrication and mass production. Multiple identical components were created with such consistency that they appear to have been manufactured rather than individually crafted. This level of standardization wouldn't be seen again until the Industrial Revolution, thousands of years later. Some researchers have proposed that the stones weren't cut and shaped at all, but rather molded using advanced concrete-like techniques. This theory suggests that ancient engineers developed geopolymer technology that allowed them to create artificial stone with properties indistinguishable from natural rock. If true, this would represent a completely different approach to construction that we've only recently begun to understand ourselves. The mystery deepens when you consider the logistics involved. The quarries where this stone originated are located miles away from the construction site. Transporting blocks weighing hundreds of tons across mountainous terrain would require sophisticated understanding of physics, engineering, and project management. Yet no evidence exists of the roads, ramps, or lifting devices that such an undertaking would necessitate. From the precise stonework of South America, let's journey to India, where ancient metallurgists created something that defies our understanding of corrosion and material science. Standing in a courtyard in Delhi is a pillar that shouldn't exist. The iron pillar of Delhi has been exposed to the elements for over 1,600 years, enduring monsoons, sandstorms, and the passage of countless seasons. By every rule of chemistry and metallurgy we understand, this iron column should have rusted away to nothing centuries ago. Instead, it stands virtually unchanged, a testament to ancient Indian mastery of material science. The pillar rises over 23 feet into the air, weighing approximately 6 tons of nearly pure iron. What makes it extraordinary isn't its size, but its composition. Modern analysis has revealed that this ancient iron contains approximately 1% phosphorus and lacks the sulfur and magnesium impurities found in contemporary iron production. This wasn't accidental. Ancient Indian metallurgists deliberately engineered this composition to create corrosion resistance that surpasses modern steel. The manufacturing process itself demonstrates technological sophistication that challenges our assumptions about ancient capabilities. Iron melts at over 1,500 degrees Celsius, a temperature that furnaces of that era supposedly couldn't achieve. Yet somehow, Indian craftsmen created this massive structure using forge welding technology that joins smaller pieces into a seamless whole. The protective mechanism involves an incredibly thin layer of crystalline iron phosphate that forms naturally on the high phosphorus content surface. This layer acts as a barrier against moisture and oxygen, the two elements necessary for rust formation. Modern metallurgists have confirmed that this protective coating actually improves over time, becoming more effective as the pillar ages. Recent attempts to recreate similar iron using ancient techniques have largely failed. Despite our advanced understanding of metallurgy and access to sophisticated furnaces and alloying equipment, modern engineers struggle to replicate the exact properties of this 1,600-year-old pillar. The ancient craftsmen achieved something that our contemporary technology finds difficult to match. The pillar's inscription credits its creation to Chandragupta II, who ruled from approximately 375 to 415 CE. This places its construction during a period when Indian civilization was experiencing remarkable advances in mathematics, astronomy, and metallurgy. The same culture that gave us the concept of zero and advanced surgical techniques was also pushing the boundaries of material science in ways that wouldn't be fully understood until modern times. But the iron pillar represents more than just advanced metallurgy. It demonstrates systematic understanding of chemistry, engineering, and manufacturing that suggests ancient Indian civilization possessed scientific knowledge that was far more sophisticated than we typically acknowledge. They weren't just lucky or stumbling upon solutions through trial and error. They were applying systematic scientific principles to solve complex technological challenges. From India's masterwork in metallurgy, let's explore another realm where ancient artisans achieved effects that seem to transcend the technological capabilities of their time. We're heading to Rome, where craftsmen created an object that demonstrates understanding of nanotechnology and optical physics that wouldn't be formally recognized until the 20th century. The Lycurgus cup sits in the British Museum, looking deceptively simple at first glance. This 4th century Roman drinking vessel appears to be made of jade green glass decorated with intricate scenes of mythological figures. But when you change your viewing angle or alter the lighting conditions, something magical happens. The cup, transforms from opaque green to glowing ruby red, as if the glass itself is alive with inner fire. This isn't some cheap parlor trick or optical illusion. The Lycurgus cup is made of dichroic glass, a material that exhibits different colors depending on whether light passes through it or reflects off its surface. When illuminated from the front, the cup appears green. When lit from behind, it glows red. The transition between these states is smooth and dramatic, creating an almost supernatural effect that would have seemed like pure magic to ancient observers. Modern analysis has revealed the secret behind this ancient nanotechnology. The glass contains microscopic particles of gold and silver, measuring only about 70 nanometers in diameter. These nanoparticles are distributed throughout the glass matrix in precisely controlled concentrations that create the dichroic effect through what we now understand as surface plasmon resonance. Here's what makes this discovery so staggering. The Roman craftsmen who created this cup were working with particles that are smaller than the wavelength of visible light. They were manipulating matter at the atomic scale, achieving effects that require understanding of quantum physics and material science that we didn't formally develop until the late 20th century. The manufacturing process would have required incredible precision and control. Too few nanoparticles and the effect disappears. Too many, and the glass becomes opaque. The concentration had to be exactly right, distributed evenly throughout the material, with particles of just the correct size to achieve the desired optical properties. Ancient glass makers somehow mastered this delicate balance using techniques that we still don't fully understand. The cup's creation represents more than just advanced material science. It demonstrates that Roman artisans possessed systematic knowledge of how light interacts with matter at the nanoscale level. They understood that tiny variations in particle size and distribution could create dramatically different optical effects. This wasn't accidental discovery. It was deliberate application of sophisticated scientific principles. What makes the Lycurgus cup even more remarkable is that it's not unique. Other examples of dichroic glass from the Roman period have been discovered, suggesting that this technology wasn't a one-time accident, but rather an established technique practiced by skilled craftsmen. Ancient Rome had developed an entire industry around nanotechnology applications that we're only now beginning to appreciate. The implications extend far beyond impressive party tricks with color-changing glassware. If Roman artisans could manipulate materials at the nanoscale for decorative purposes, what else were they capable of? Did they apply similar techniques to other materials? Were there practical applications of this technology that we haven't discovered yet? These questions lead us to consider a broader pattern that emerges when studying these ancient technologies. Time and again, we discover that our ancestors achieved results that seem impossible given our understanding of their technological capabilities. They created analog computers without electricity. They generated electrical current without understanding electromagnetic theory. They forged superior metals without modern chemistry. They built self-healing concrete without polymer science. They manipulated light at the nanoscale without quantum physics. Each discovery forces us to reconsider our assumptions about technological progress and human capability. Perhaps the linear model of advancement that we take for granted doesn't reflect historical reality. Maybe ancient civilizations developed sophisticated technologies through paths that we haven't explored or understood. They might have achieved remarkable results using methodologies that seem alien to our modern scientific approach. The pattern suggests something profound about human ingenuity and problem-solving capability. Given enough time, observation, and experimentation, our ancestors could achieve technological breakthroughs that rival or exceed our contemporary capabilities. They didn't need to understand the theoretical framework that we use to explain their achievements. They just needed to pay attention to what worked and refine their techniques over generations. This raises uncomfortable questions about our modern assumptions regarding technological superiority. We tend to believe that our current level of advancement represents the pinnacle of human achievement, that we've surpassed all previous civilizations in every meaningful way. But the evidence suggests a more complex reality, where ancient cultures achieved specific technological peaks that we're still trying to match or understand. The mystery deepens when we consider how much knowledge has been lost over time. Wars, natural disasters, political upheavals, and simple neglect have destroyed countless libraries, workshops, and centers of learning throughout history. The technologies we've discovered might represent only a tiny fraction of what ancient civilizations actually achieved. How many other incredible devices lie buried beneath our feet, waiting to challenge our understanding of the past? How many revolutionary techniques died with their creators, leaving no trace except perhaps some inexplicable artifact that archaeologists haven't yet recognized for what it truly represents? These questions point toward a humbling conclusion. Our ancestors weren't primitive people struggling to survive with crude tools and superstitious thinking. They were sophisticated engineers, scientists, and inventors who solved complex problems using intelligence, creativity, and systematic observation. They achieved technological marvels that continue to amaze and confuse us today. The devices and techniques we've explored represent more than just historical curiosities or archaeological mysteries. They're evidence of human potential that transcends the artificial boundaries we impose on technological development. They remind us that innovation and discovery aren't monopolized by any particular era or culture. Throughout history, brilliant minds have pushed the boundaries of what's possible, creating technologies that seem to defy time itself. As we reach the end of this incredible journey through impossible ancient technologies, one final mystery demands our attention. Hidden in museums around Europe are dozens of small bronze objects that have puzzled archaeologists for over a century. They're called Roman dodecahedra, and despite extensive study, no one can definitively explain what they were used for. These 12-sided copper objects date back to approximately 100 to 400 CE, scattered across the former Roman Empire. Each dodecahedron features 12 pentagonal faces with circular holes of varying sizes. Some have small knobs at their corners. Others show signs of wear that suggest regular use. But their purpose remains completely enigmatic. The craftsmanship required to create these objects was considerable. Forming 12 perfect pentagonal faces from bronze required advanced understanding of geometry and metalworking techniques. The precision of the holes suggests they were measured and cut with specific purposes in mind. Yet no Roman text mentions them. No artwork depicts them being used. They exist in a historical vacuum that makes interpretation nearly impossible. Theories about their function range from practical to mystical. Some researchers suggest they were surveying instruments used to measure distances or angles. The varying hole sizes could correspond to different measurement standards or viewing apertures. Others propose they served as candle holders, with the holes allowing light to project specific patterns for religious or ceremonial purposes. More intriguing possibilities involve their use as astronomical instruments. The dodecahedron's geometric properties relate to celestial mathematics in ways that ancient astronomers would have understood. Perhaps they were portable devices for calculating planetary positions or determining optimal times for agricultural activities. The relationship between their form and function might reflect sophisticated understanding of mathematical principles that we haven't fully appreciated. Another theory suggests they were tools for rope or chain making, with the holes sized to create uniform lengths or measurements. The wear patterns on some specimens support this practical application, though it seems almost mundane for such geometrically complex objects. Would Roman craftsmen really invest so much effort in creating elaborate tools for such simple tasks? The distribution pattern of these artifacts adds another layer of mystery. They've been found primarily in northern regions of the empire, concentrated in areas that were heavily militarized. This geographic clustering suggests possible military applications, though what those might have been remains unclear. Were they specialized tools used by Roman engineers, instruments for battlefield surveying, components of larger devices that have been lost to time? What makes Roman dodecahedra particularly fascinating is their apparent obsolescence. Unlike other Roman technologies that influenced later civilizations, these objects simply disappeared from the archaeological record. Whatever they were used for became unnecessary or forgotten, leaving behind only these enigmatic bronze puzzles for modern archaeologists to ponder. The existence of these mysterious objects reminds us how much we don't know about daily life in ancient civilizations. We tend to focus on the grand achievements, the monumental structures and famous inventions. But ordinary people were using sophisticated tools and techniques that have been completely forgotten. The dodecahedra might represent just one example of countless technologies that were once commonplace but have vanished from historical memory. This brings us to a sobering realization about the fragility of technological knowledge. Throughout history, entire civilizations have risen and fallen, taking their innovations with them. The Library of Alexandria burned, The Western Roman Empire collapsed. The Islamic Golden Age ended. The Ming Dynasty's treasure fleets stopped sailing. Each time, invaluable knowledge disappeared, sometimes forever. Consider how much has been lost just in recent centuries. Traditional crafts that took generations to perfect have been abandoned in favor of mass production. Indigenous technologies adapted to specific environments have been replaced by standardized global solutions. Languages that contained unique ways of understanding the world have gone extinct, taking their accumulated wisdom with them. The pattern repeats throughout human history. Knowledge accumulates slowly through careful observation and experimentation. Masters pass techniques to apprentices over generations. Then war, disease, economic collapse, or simple neglect breaks the chain of transmission. What took centuries to develop can be lost in a single generation. This vulnerability of knowledge makes the ancient technologies we've explored even more remarkable. They survived not because they were carefully preserved, but through sheer luck. A shipwreck protected the Antikythera mechanism from destruction. Roman concrete structures were too massive to tear down completely. The iron pillar of Delhi was revered enough to receive basic maintenance. Zhang Heng's earthquake detector was documented in historical records that happened to survive. How many other incredible inventions weren't so fortunate? How many ancient computers corroded away to nothing? How many superior alloys were melted down for scrap metal? How many architectural techniques died with the last master builder who understood them? The artifacts we've discovered might represent only the tiniest fraction of what once existed. This realization should inspire both wonder and urgency. Wonder at the incredible ingenuity our ancestors demonstrated in creating technologies that continue to amaze us today. But also urgency in recognizing that our own knowledge is just as fragile, just as vulnerable to loss through neglect or catastrophe. The ancient devices we've explored tonight challenge our most basic assumptions about technological progress and human capability. They force us to acknowledge that innovation doesn't follow a simple linear path from primitive to advanced. Sometimes, brilliant minds achieve breakthroughs that seem to defy their historical context. Sometimes, knowledge advances, then retreats, then advances again along completely different paths. These discoveries remind us that every civilization believes itself to be at the pinnacle of human achievement. The Romans thought their engineering was unsurpassable. Medieval craftsmen believed they had perfected metallurgy. Victorian inventors were convinced they had unlocked all of nature's secrets. We're probably just as wrong about our own technological superiority as they were about theirs. These extraordinary examples of ancient ingenuity prove that human brilliance isn't bound by the era we happen to live in. Our ancestors achieved technological marvels that still baffle modern engineers, reminding us that innovation and discovery belong to no single civilization or time period. Perhaps the greatest mystery isn't how they created these impossible devices, but what other incredible technologies lie buried, waiting to rewrite everything we think we know about the past.